Hi, my name is Karnnithi Raktapongpaisal. I'm from M18. My number is number 10. And today I'm going to be talking about my answers from this exam. So let's start from number one. Number one, uh, for A, it asks for which which it is, uh, a shaft-based system or a hole-based system. Well, if you look at this and translate it to the chart, we can see that the shaft is smaller than the hole. So that's why I chose hole-based system. For B, we have to find the maximum shaft. So for how to find it, we choose the lowercase letter and translate that into the chart. You have for G6, you have -9 and -25. So to find it, we have to divide both of these numbers by 1000, which you can see here is the answer, and pick the top one if you want maximum, or if you want to find minimum, you pick the the bottom one. So I'm finding maximum, so I choose the top one. And the formula is that you have to put the number over here, 45, and minus it with the maximum. And this will be the answer. So for C, it asks to find C max and C minimum. So these are the formula. And to make this easier, I divide it into two parts, shaft diameter and hole diameter. So I find the maximum and minimum of all of them, in which you can see here, this is shaft max and shaft minimum. This is hole max and hole minimum. And put these numbers into the formula. So as you can see, HD max, I will put this into that, and this is SD min, so I put this into that, minus them, and boom. Do that for C minimum too, but they're not the same formula, so use this formula, and you get the answer. For TF, we have to get C max and C min and minus each other. So we got them here already. So we just need to minus them, and this will be the answer. And for E, it asks what type of what type of fit system is this? And I chose clearance system because the shaft is smaller than the hole. On to the next question number two. Uh, in this one, it shows us a picture, and we have to answer what it is. The first one shows a spring, so I chose compression spring because that's the only one other than tension spring. But tension spring is tighter and more compact. B, it shows M thread, so I chose M thread as answer, sorry, and it asks what is its drawing symbol. It gave us the major diameter of 20 and the pitch of 3. So to do this, I just put M and then 20 times 3. This is the major diameter and this is the pitch. The next one is the same. So it shows a Whitworth thread, so I wrote down Whitworth, and it shows a drawing symbol, but it asks us what is its major diameter and what is its pitch. So I answered that because it was W, which stands for this, Whitworth, W 1 times 2 over 8. So the first one, like for example, like this, the first one is major diameter, and the second one that comes after the times is the pitch, 2 over 8. For D is the same, but different type of thread. This is a square thread, and it also shows us the drawing symbol and ask the measure diameter and pitch length. So I did the same thing. The last one, it just asks what type of gear is this, and it shows a worm gear. So I put down a worm gear. For number three, it shows us many pictures and lists a bottom A, B, C, D to J, and it asks to match the picture with the words. So for 2.1 is G, a trapezoid thread. For 2.2 is Acme thread, B. 2.3, I, and a unified screw thread. 2.4, a buttress thread, E, a buttress thread. 2.5, H, left-handed thread. 2.6, F, flat belt. 2.7, C, a spur gear. 2.8, J, a rack gear. 2.9, D, a helical gear or a bevel gear. And 2.10 is A, right-handed thread. Onto the next page. I didn't finish all of them, but I did most of them. There are all of them total 7 questions, but I only did into 5, so 6 and 7 will not be answered. So for 4, it gave us a diagram and it asked us what is each step, what is the time it took to uh, cut it. And it already gave us the cutting time, cutting rate at 10 centimeters square a minute. So we just need to do some calculations. So A2 is the area of where we're cutting. So it shows in the diagram. So we put 150 millimeters to A2 and 10 to cutting rate and divide them, we get 15 minutes. For this one, we don't get the A2, but we have the A1, which is the diameter of the rectangle, sorry, and it is 200. So the formula is A1 divided by cos sigma. Sigma is the angle of the cutting, so the angle is 45, and we just put that there. The A1 is 200, and divide that all together, you get 282.84. Now, to find the time, like this one, we put A2, which is this, on top, and cutting rate, which is 10 at the bottom. We divide it, we get 28.284 minutes. For C is same as A. We have the cutting diameter. It is 325 millimeters, and the cutting rate is 10, which I forgot to put here, sorry. Divide that, we get 32.5 minutes. The next one, which is the last one for me, it shows, it tells us that there are two driving and driver pulley. And for this one, it wants to find the surface speed of the small one. So I put this formula. D is the diameter of the pulley, and N is the rounds per minute, RPM. So put that together, we get pi times 600 times 400 divided by 1000 equals to 753.9 meters per minute. B, it asks us to find the rotational speed of the big one, the big pulley, and the speed ratio. So we use this formula, N1 divided by N2 equals to D2 divided by d1. We have three values that we know, so we put that here. N1 is 400, D2 is 1800, D1 is 600. And we transfer this over to the other side so we can find N2 and times it together, you get 1200 RPM. So now that we find N2, we can find the speed ratio. Put all the numbers in here. I forgot to write 1800 here, sorry. And together, sorry, not together, this one, the rotational speed, you get 0.3, and for the 1800 divided by 600, you get 3. To simplify this, you just have to divide it by 3 because you can simplify this. It will be into 0.1 to 1 ratio. Thank you very much and goodbye.